Hello, today we're going to talk about the direction of reversible reactions. So just a brief reminder about a couple things with equilibrium that are going to be really important, reactants and products. When it reaches equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. Okay, so the rates are equal. The amounts of reactants and products do not have to be equal. They could be, but they're not necessarily equal. Okay. And then the reactions do not stop. It's a dynamic equilibrium. So the forward reaction and the reverse reaction keep going, but they're going at a constant rate. So that's what makes your amounts constant. Your amounts are constant, but they're not necessarily equal. All right, so we have reactants and products, right? Let's say, for example, you start out a reaction and you have only reactants in your flask or whatever. That means that the reaction is going to proceed in the forward direction at a much faster rate until it reaches dynamic equilibrium. Now, if you have the opposite scenario, reactants going to products, if you have mostly products or even only products, that means the reaction is going to proceed mostly in the reverse reaction until it reaches that dynamic equilibrium. Okay, so in this example, we have nitrogen reacting with hydrogen, and it's forming 2 ammonia. That's the forward reaction, but you also have the reverse reaction. And it says it's at equilibrium at 500 Kelvin. And it says what happens to the rate of the forward and reverse reaction if you add some NH3. All right, so you have a system at equilibrium, and then suddenly you add an extra product. All right. When you're adding in that extra product, it's no longer at equilibrium. So in order to get to equilibrium, we need to use up some of that extra NH3. So the reaction is going to proceed in the reverse reaction. So the rate of the reverse reaction will increase, and the rate of the forward reaction will decrease until it regains equilibrium. Then the rates will be constant again. Okay, so in this one, in a previous evacuated 1 liter flask, so it's empty flask. We've got 0.4 moles of A and 0.5 moles of B were added and allowed to come to equilibrium. At equilibrium, there were 0.15 moles of C. And the equation for the reaction is A plus 2B yields C. Sketch 3 curves to show the reaction as it reaches equilibrium. Okay, so let's go ahead and start out our axes here. And at the very beginning, we didn't have any C because it said just A and B were added in, so I don't have any C. And I'm going to try to label this nice and neat. 0.1, 0.2, 0.3, 0.4, 0.5, 0.5. And so that is where B is starting, and 0.4 is where A is starting. And then at equilibrium, they tell us there are 0.15 moles of C. So that means it must increase till it gets to just about here, 0.15. Now, we know that A and C have the same mole ratio. It's 1-to-1 ratio. So if C is increasing by 1.5, then A must be decreasing by 0.15. So if we have our 0.4 moles minus the 0.15 moles, we get 0.25 for A. So A is going to go down to about here to 0.25. That's 0.15. All right, now for B, B is being used up twice as fast as A. So if B is starting at 0.5, at equilibrium it's going to go down by twice as much. So it's going to go down by 0.3, and you'll be left with just 0.2 for B. So B is going to wind up here at 0.2, like that. And it's reaching equilibrium here. And so this is for A, B, and C.